Hello, my name is Vignesh, and this is going to be lecture number 9 in the math lecture series. Today, we're going to be going over lines and linear models, which is a topic hopefully many of you have gone over in your previous math classes, but this could be a good review, as well as going to be give you an example of how you may be quizzed or like tested on this topic on the actual SAT. So as usual, these notes as well as the practice problems and the answers are posted on Google Classroom. I highly suggest before you watch this video, or maybe right after this, before I do the practice problems, a couple of the practice problems, you go back and you go over the note, you look at the notes and then you go over the notes as well, or at least at the very least do all the practice problems so you can make sure that you truly have mastered this topic, as well as go online and find some extra practice problems. However, if you're not, if, watching this video could give you a good review. But the first topic I'm going over is slopes. So slope is very simple in like the form, if it's y equals mx plus b, slope is m. And in this case, slope is rise over run, or it's the change in y value over the change in y value. So change in y value over change in x value. So for instance, if your y value goes up by 4, but your x value goes down by 2, it's going to be -4 with -2. That's basically what it means. It's how the vertical change over the horizontal change. So yeah, and you can also have point slope form, which is y minus y1 equals m times x minus x1. So how this would usually be is like, let's say you had a point 2 comma 8 and the slope is 5. And in this case, it would be y minus 8 equals, sorry, let me write a little bit, let me make this bigger so I can write y equals, sorry, oh wait, sorry about that. Yeah, it would be, let me just read it. It's going to be y minus 8 equals 5 times x minus 2. So that's basically what slope form is. You basically use a slope and a point to write the equation. And obviously you could like distribute this and then move it to change it into y equals mx plus b form, which is usually easier for you to determine y-intercept and all that jazz. But yeah, anyway, so that's basically how you find slope and slope interval form. And obviously, in like if it's a positive slope, it'll graph will look like this. If it's a negative slope, the graph will look like this. That's something you should know. As well as in like usually a slope in like a word problem is like the change from the initial value. So let's say the initial value is like 20, and like you're subtracting 4, so it'd be per like thing, it'd be like minus 4m, something like that. That means you're subtracting 4, so you start like 20, and then you go down by 4 every time. So yeah, that's basically just an example of like how you can get in a word problem. Next we have intercepts. That is just the y-intercept and the x-intercept. The x-intercept is when y is equal to 0. So let's say you had y is equal to 5x plus 2. The x-intercept would be when y equals 0, so 0 equals 5x plus 2. And so it would be x is equal to -2/5 if you solve for x. That's how you would solve for the x-intercept. Y-intercept is much simpler. It would just be this b value right here. So it would be 0, 2. Usually when they ask for the intercept, it's in the form of like 0, 2, or it's just 2. But yeah, so that's basically how you find x and y-intercept. And like I said, y-intercept is usually the initial value in like a word problem. So in the case when it was like 20 minus 4m, it's you can make that into -4m plus 20. So in this case, 20 would be the y-intercept and the initial value. So yeah, and we also have some other specific scenarios. So let's say you had, this is a bad sketch of a graph. Let's say you had two parallel lines. It's not really parallel, but you get the idea. Then they never touch and their slopes are the exact same, but the y-intercept is different. And let's say you had two perpendicular lines. In this case, they make a right angle and the slopes are negative reciprocals of each other. So like in this case, if one slope is 4/5, the other one is -5/4. So you flip the fraction as well as you put a negative sign. So if it's -4/5, it would just be +5/4, like that. And if we have horizontal and vertical lines, so a vertical line would just be something like this. And in this case, it's whatever this point is, it would be x is equal to, let's say 5. That's what the line, like the slope, like the equation to the line is going to be, and horizontal is basically the exact. I don't know why I'm doing that. Horizontal is basically the exact same, except it's for y value. So like in this case, if this is the line right here, then it's going to be like y equals 4, something like that. That's basically it. And now we're going to go over a couple of questions so you can get an idea of the type of questions. And again, this is all going to be on Google Classroom. Please look over the questions, do both the problem sets and check your answers. And if you need extra help, go online. But yeah, it's very good. But even if you know like this topic, and it's a pretty simple topic, doing more practice can never help because it shows you the type of questions SAT can ask on this topic. Because like I usually say on the math section, the easiest way to just go high is to continuously do practice problems, so you know all the different ways SAT can answer the question. But yeah, so the first question I'm gonna go over is number 5. I'm just gonna go over like 2 in each problem set. There's 2 different problem sets because this is like I use like 2 like in the book I use for the problem sets. It's like 2 different chapters, so I condensed it onto one. But yeah, so number 5, y is equal to ax plus b and y is equal to negative bx. The equations of 2 lines in the xy plane are shown above, where a and b are constants. If the 2 lines intersect at 2, 8, what is the value of a? So we know they intersect at 2, 8. So I'm already going to plug this in already to the 2 equations. So 8 is equal to a times 2 plus b. And the other one is 8 is equal to negative b times 2. So first I'm going to solve for b because I using both of them, but in this second equation, it's the sole variable, so it's easy for me to solve. So in this case, negative b, that would be 2b is equal to, so let me solve this down here. This would be, if I'm solving this down here, it would be 2b is equal to negative 8, b is equal to negative 4. So if b is equal to negative 4, we plug this into the other one. So 8 is equal to 2a minus 4. 2a equals 12. And divided by 2, a is equal to 6, which means the answer is C. Okay, number 12. The equations of 2 perpendicular lines in the xy plane are shown above, where a, b, c, d, and e are constants. If a over b is between 0 and 1, so it's less than 1, but it's a positive number, which of the following must be true. So in this case, what I want to do is to give myself an example, I would just pick a random fraction between 0 and 1. So let's say 1/2. So I know that it's a over b let's say a over b is 1/2, and this is perpendicular to d over e x plus c, right? So what that means is that means it's going to be a what's called a negative reciprocal, right? So negative reciprocal of this will just be -2. So which one of these is so d over e is going to be equal to -2 because that's how the slope works. So in this case, d over e is less than -1. Is -2 less than -1? Yes. So that works so far, but let's just do over the other ones just to make sure. D over e is between -1 and 0? No. D over e is between 0 and 1? No. D over e is greater than 1? No. It's -2. So all these are wrong. So A is the only right answer there. Okay, we go on to the next problem set. Number 7, the equation above can be used to model the number of hours h until a gallon of milk held at the temperature of T in degrees Celsius goes sour. Based on the model, which of the following is the best interpretation of number 4 in the equation? So in this case, we can already tell this -4t, that's going to be the slope because it's next to the variable. Because this just as if you want to put in the y mx plus b, this would just be h is equal to -4t plus 100. We make this t like that, so it's yeah, plus 100. So but 100 is our initial value, right? So I'm going to go over these things and see if it works. Okay, an increase of 1 degree Celsius will make a gallon of milk go sour 4 times faster. So if I increase t by 1, so let's say I go from 0 to 1, that'll be from 100 to 96. And so that means it's going. And if we don't have the eight, this sorry, h is how many hours until the gallon of milk becomes sour. So if it goes from 100 hours to 96 hours, that's going 4 hours faster, right? So far A looks like the right answer. But if I go over the other ones, increase of 1 degree Celsius will make the would make 4 gallons of milk go sour 1 hour faster. In that case, that would have to mean that after 4 hours it would be 100 to 99. However, we see after 4 hours it goes down by 16 hours. It goes 16 hours faster. So we know B is wrong. increase of 4 degrees Celsius will make a gallon of milk go sour 1 hour faster. So if we increase by 4 degrees, remember it's not 1 hour, it's going to be 16 hours. Okay, and then D, an increase of 4 degrees Celsius. Wait, I think for B, my explanation is wrong. But like, so why B is wrong? So I confused it with C. So why B is wrong is because it says to make 4 gallons, but we don't know how 4 gallons work because we only know about 1 gallon, and a gallon is not a variable anywhere. So we can't tell for sure if it's going to be the same for 4 gallons. So that's why B is wrong. I mixed up B and C, yeah. But C is wrong because of the 4 degrees Celsius will make it go 1 hour faster. That's the 16 thing. That doesn't work. An increase of 4 degrees Celsius makes a gallon of milk go sour 4 times hours faster. No, it's 1 degree Celsius that makes it go an hour faster. For it to be 4 degrees Celsius, that means it has to be like 1 over 4 T. That's how that would have to work, or something like that. So yeah, so that's why this is wrong. That's why A is the right answer for 7. Okay, fine. I'm going to go over number 16. A local post office uses the equation above to determine the cost C in dollars of mailing a shipment weighing 8x pounds. So I'll put this into xy equals mx plus 1.5x plus 1.5. An increase of $10 in the mailing cost is equivalent to an increase of how many pounds in the weight of the shipment. So increasing something by 10 pounds, that's not going to affect this, like the base amount, the 1.5, because the 1.5 you pay no matter what. So by increasing anything by 10, it's not going to affect the base. So if we want to know how much pounds in the weight, how much the increase of the weight would be, then we don't need to deal with that. So the cost goes up by 10, right? So that means 2.5x has to equal 10 for me to know what the increase has to be. So I divide both sides by x, 2.5, that gets x equals 4. So in this case, 16 is C. So and how to reason this is basically why did 2.5x equals 10 is that, like I said, this initial value does not matter because I'm saying it's an increase of 10. So the only thing that matters is the slope and the slope. So if the cost goes up by 10, then that means x value has to go up by a certain, and we don't know how much x value goes up. If the cost goes by 10, that means we have to divide cost by the slope to get the how much it would have to be, x would have to go up. In this case, x has to go up by 4, as I see the answer there. So yeah, that's basically. I hope this gives you a taste of like the lines and linear models. And like I said, like I keep saying, go to a Google Classroom. If you're not in a Google Classroom, the code is in the link in the description. The code is in the description. So yeah, so just click on it and join the classroom and look at these practice problems and do a couple of them and hopefully do all of them and check your answers at the very end and where there's questions and there's explanations for each question. And if you need any other help or you're confused about anything, you can email me at vigneshkumarus@gmail.com. I think it's also in the Google Classroom, my account. So yeah, so that's basically it. Thank you. Have a nice day and wish you the best of luck on your SAT journey.